Hello everyone, we are back with another video on kinematics. What we have studied, we have scalars and vectors, unit vector, position, displacement vector, and resolution of a vector. This was done in the previous video. Now what we are doing laws of vector addition, that is triangle, parallelogram, and polygon law, and its analytical treatment. What you should be knowing: what are scalars, what are vectors, what is a unit vector, what is its formula, I, j, and k, that is unit vectors along x, y, and z axis, position vector, displacement vector, and Pythagoras theorem. Now, vector addition by graphical or geometrical method. So what is the general rule? It states that the vectors to be added are arranged in such a way that the head of the first vector coincides with the tail of the second vector and so on. Then the single vector drawn from the tail of the first vector to the head of the last vector represents the resultant vector. So let's take the first case, vectors acting in the same direction. This is vector A, this is vector B. We need to add them head to tail. So this is vector A, vector B is added to it, head to tail. We get the resultant shown by the black arrow, which is equal to A plus B. Okay, so when they are in same direction, it's simply added. Yes. Vector acting in opposite direction. So this is vector A, this is vector B. We need to add them head to tail. Okay, it is added. You can see the resultant is equal to A minus of B. So this part is the resultant now, because from the total this part got subtracted because this was in opposite direction. Now, if vectors are acting at an angle, then there is something called as triangle law. It says if two vectors acting on a particle at the same time are represented in magnitude and direction by the two sides of a triangle taken in the same order, then the resultant is represented in magnitude and direction by the third side of the triangle taken in the opposite order. So I have vector A, vector B, they are acting on a body. Okay, they are acting on a body and they are represented by the two sides of a triangle taken in the same order, that is tail to head, tail to head. Then the resultant is represented by the third side of the triangle taken in the opposite order, that is here also tail to head, from tail of vector A to the head of vector B. So R is equals to A plus B. Okay. Parallelogram law. If two vectors acting on a particle at the same time are represented in magnitude and direction by the two sides of a parallelogram, you can see it is represented, okay, by the two adjacent sides of a parallelogram drawn from a point, then the resultant is represented in magnitude and direction by the diagonal of the parallelogram drawn from the same point. So as you can see, the resultant of vector A and B is R, which is equal to vector A plus vector B. Now, case 4, when number of vectors act in different directions. So there we get the Polygon law, which says if any number of vectors acting on a particle at the same time are represented in magnitude and direction by the various sides of an open polygon taken in the same order, then the resultant is represented in magnitude and direction by the closing side of polygon taken in opposite order. So I have these four vectors. Okay, now vector A, vector B is added head to tail. The resultant is A plus B. Now see, now what is the resultant of A plus B and C? Which is A plus B plus C. Okay, now what is the final resultant? That is R is equals to A plus B plus C plus D. This is called as Polygon law. Now, examples of parallelogram law of vector addition. The first one is flight of a bird. You can see the bird flying. Now we are taking, okay, this is the case. During flight, the bird pushes the air with forces F1 and F2. So this is force F1, this is force F2 in downward direction with the help of its wings. As you can see here, the bird is pushing in the downward direction with the wings. Okay, the line of action of these forces meet at point O. Okay, now the air exerts equal and opposite reaction forces R1 and R2. So here I am representing the reaction forces by the red arrows. So it is R1 and R2. From the parallelogram law, the resultant of these vectors R1 and R2 acts on the bird in the upward direction with the resultant vector R, and it helps the bird to fly upwards. The second example is slingshot. As you can see in this animation, this slingshot, how it works. Let's have this picture. So when a stone held at point O, so this is point O, is pulled, the tensions T1 and T2 at points A and B. So OA and OB represent the tension T1 and T2 produced along OA and OB in the two segments of the rubber band. Now from parallelogram law of vector addition, the resultant T of T1 and T2 acts on the stone along OC. Now let us do the analytical treatment of vector addition. So first we will do for triangle law. Consider two vectors A and B inclined at an angle theta, by acting on a particle at the same time, and are represented in magnitude and direction by the sides OP and PQ of triangle OPQ taken in the same order. So this is the representation of vectors A and B by the two sides of a triangle. Then the resultant is R. Now what about the angle theta? Yes, the angle theta is between the two vectors A and B, and the angle is always between the tails. That's why this is the angle theta, not this angle. Okay, now this was the resultant R. Now produce OP to N. We have done that. And draw QN normal to OP. We have done that. Now in triangle ONQ, according to Pythagoras theorem, OQ square is equal to OP plus PN whole square plus QN square. Now we only know PQ and OP. We don't know PN and QN. So let's find them. In right angle triangle PNQ, yes, this triangle. What about cos theta? Cos theta is PN by PQ, which will give us Pn by B, or Pn is equal to B cos theta. Yes, this is B cos theta. Let's find sine theta, which is Qn by PQ, which is Qn by B, or Qn is equal to B sine theta. We will put these values of Pn and Qn in equation number 1. So what we get, R square is equal to A plus B cos theta whole square plus B sine theta whole square. On solving, we get R square is equal to A square plus B square plus 2AB cos theta, which is the magnitude of the resultant. You can have R is equal to under root of A square plus B square plus 2AB cos theta. Let's find out the direction. Let the resultant R makes an angle beta with the direction of vector A. So what about tan beta? Tan beta is Qn by On, which is equal to B sine theta upon A plus B cos theta. Now let us do the analytical treatment of vector addition for parallelogram law. So we have the two vectors A and B represented by the two sides of a parallelogram. So resultant is R, and the angle between the vectors is theta. Again we will produce OP to N, and we will draw QN perpendicular. Again we will take triangle ONQ, Pythagoras theorem we will use. Then we will take triangle PNQ, we will find cos theta. From that we will find Pn is equal to B cos theta. With sine theta we will find Qn is equal to B sine theta. We will put the value of Pn and Qn in equation number 1. And then what we get, R square is equals to A square plus B square plus 2AB cos theta. Then this is the magnitude, and this is also called as law of cosine. We need to find the direction, so let the resultant r makes an angle beta with direction of vector a. So in right angle triangle ONQ, tan beta is equal to Qn by On, which is b sine theta upon a plus b cos theta. So let us find out what is this law of sines. In triangle ONQ, sine beta is equal to Qn by OQ, which is b sine theta upon r, or can I write r sine beta is equal to b sine theta, or can I write r upon sine theta is equal to b upon sine beta. Let me name this as equation number 2. Now let us draw PM perpendicular to OQ and let the resultant makes an angle alpha with vector P. So in triangle OMP, that is this triangle I am talking about, sine beta is PM by OP, which is PM by A, or can I write PM is equal to A sine beta? I call this as equation number 3. In triangle QMP, sine alpha is equals to PM by PQ, which is PM by B, or can I write PM is equal to B sine alpha? Now from 3 and 4, can I write A sine beta is equal to B sine alpha, or A upon sine alpha is equal to B upon sine beta, which is equation number 5. Now we will compare it with equation number 2, and what we get, R upon sine theta is equal to A upon sine alpha is equal to B upon sine beta. In simple terms, the vector upon sine of the angle opposite to it. The vector upon sine of the angle opposite to it. The vector upon sine of the angle opposite to it. This is law of sines. Now we found out the magnitude, which was r is equals to under root of a square plus b square plus 2ab cos theta. Direction also, tan beta is equal to b sine theta upon a plus b cos theta. Now let us do a few special cases. Okay, so when theta is 0, r is equal to a plus b, tan beta is equals to 0, that is beta is equals to 0. So this is the case when the vectors are acting in the same direction. We simply add to get the resultant. If theta is 180, r is equals to a minus b, tan beta is equal to 0, that is in the direction of the bigger vector, or 180, that is direction of the vector which is bigger but in the opposite direction. So this is vector A, vector B. In this case scenario, angle is 0. If vector B was greater, then R would have been in a direction opposite to A, so I would have taken angle as 180. Case 3, when theta is 90, so R is equal to under root of A square plus B square. Tan beta is B by A, that is beta equal to tan inverse of B by A, and the resultant is R. So you can see the diagram also. Now let us find out some important points related with vector addition. So vectors of same nature along can be added. Second property, vector addition is commutative, that is vector A plus vector B is equal to vector B plus vector A. So A and B are two vectors. Resultant is R is equals to A plus B in triangle OPQ. Now let's take another Now let's do a few examples. The first one, what is the angle between two forces of 2 Newton and 3 Newton having resultant of 4 Newton? So A is 2 Newton, B is 3 Newton and R is 4 Newton. Let's apply parallelogram law. R square equal to A square plus B square plus 2AB cos theta. Let's put all the values. We get cos theta is equal to 1 by 4, or theta is equal to cos inverse 1 by 4, or theta is equals to 75.52 degrees. Question number 2, two forces 5 and 10 kg weight are acting with an inclination of 120 degree between them. What is the angle which the resultant makes with 10 kg weight? Now we want the angle with 10 kg weight. That means A is 10 and B is 5. So A is 10, B is 5, theta is 120. We know 10 beta is equal to B sine theta upon A plus B cos theta. We put all the values. Sine 120 is root 3 by 2, cos 120 is minus 1 by 2. And what we get on solving? We get 1 by root 3, that is beta is 30 degrees. This is a very interesting question. On an open ground, a motorist follows a track that turns to his left by an angle of 60 degree after every 500 meter. Starting from a given turn, specify the displacement of the motorist at the third, sixth and eighth turn. Compare the magnitude of the displacement with the total path length covered by the motorist in each case. So let's take that the motorist be at point P. Okay, he starts from point P, then he takes the first turn at point P after covering 500 and the angle is 60 degrees. So first turn, okay, he reaches point C, again 500 meter, then he takes the second turn making 60 and previously it was 60, so the total is 120 degrees. Okay, and then he takes the third turn at D, and this was the first. We need to find at the third turn. So distance is AB plus BC plus CD, which is 500 plus 500 plus 500, that is 1500 meter. Now the displacement is AP plus PD. AP is 500. What about PD? Okay, so we have taken triangle PCD. In triangle PCD, PD is equals to under root of PC square plus CD square plus 2PC into CD into cos 120 using the triangle law. We put all the values. We get PD is equals to 500 meter. So the displacement is 500 plus 500, that is 1000 meters. Now let's continue for the sixth turn. So this was third. Now he covered 500 again. Then he took the fourth turn at E. He covered 500. Then he took the fifth turn at E. Again covered 500. And then he took the sixth turn at A. So the distance is AB plus BC plus CD plus DE plus EF plus FA. That is 500 plus 500 plus 500 plus 500 plus 500 plus 500. That is 3000 meters. Now the displacement is 0 because the initial and final position is same, that is A. Now let us continue for the 8th turn. This was what happened earlier. Okay, now he moved. Then he took the 7th turn at B and he took the 8th turn at C. So the distance is AB plus BC plus CD plus DE plus EF plus FA plus AB plus BC, that is equal to 4000 meter, and the displacement is AC. So in triangle ABC, yes, this was the angle 60, so AC is equal to under root of AB square plus BC square plus 2ABBC cos 60, that is under root of 500 square plus 500 square plus 2 into 500 into 500 into 0.5, which gives AC is equals to 500 root 3 or 866.03 meters. Let's do question number 4. The simple sum of two forces acting at a point is 16 Newton and their vector sum is 8 Newton and its direction is perpendicular to the smaller force. Find the forces. So let the smaller force is having a magnitude A and the larger force is having a magnitude B and R is the resultant. Okay, so by Pythagoras theorem, B square is equal to R square plus A square. Let's put the value of R. What we get, B square minus A square is equal to 64. Let's name it as equation number 1. In the question itself, it is given A plus B is equal to 16. That means B is equal to 16 minus A. We put in equation 1 and solve. And what we get, A is equals to 6 newtons. So if A is 6, B is definitely 10 newtons. Let's move to question number 5. A particle has a displacement of 12 meter towards east and 5 meter towards the north and then 6 meters vertically upward. Find the magnitude of the sum of these displacement. Okay, so this is vertical. Now, if this is taken as vertical, then we need to take the north-south at a different part. That's why we have taken slightly different. Now from O to A it is 12 meter, then it is towards north 5 meter, then it is towards the vertical 6 meters. So in triangle OAB, OB is equal to under root of OA square plus AB square, that is under root of 12 square plus 5 square, that is under root 169, that is OB is equals to 13 meter. Again in triangle OBC, OC is equal to under root of OB square plus BC square, that is under root of 13 square plus 6 square, which gives under root of 205, or OC is equals to 14.32 meters. Now let us recap what we have studied. Okay, what is vector addition, what is triangle law, vector A, vector B, R is A plus B, then the parallelogram law. Okay, magnitude is R is equal to under root of A square plus B square plus 2AB cos theta. Direction is tan beta is equal to B sine theta upon A plus B cos theta. Examples for flight of bird and slingshot. Then we did the polygon law, if a large number of vectors. So now is the time for a few questions. So these are 7 questions for you. Do try them and check the next video for the solutions. And at the end, I am thankful to Google and Bing for the images that they have provided. Thank you so much. Do watch the next video for the solution of this assignment. Thank you so much.